Now you're ready to see just how easy it is to declare a variable in C++. And by declare a variable, of course, I mean to reserve memory on your computer for values. Okay. I've already gone ahead and started us a new program for looking at variables. Note, I've got some information up here. Don't forget, at the very least, you're going to want to have the file name and some type of little description there, so that when you go back and look at it, you'll be like, oh, okay, that's what this program is for. So we talked all about that and how to create a project and get this file open and everything back in topic 3. So if you need to review, you can go back there, and we have a video for Visual Studio and one for Eclipse. And just as a quick little reminder, remember this is just for Visual Studio. So go back and review those videos if you need to. Alright, so when we create a variable, we are reserving memory for some data, for a value of some sort or some type. And before we can use a variable, we have to create it. So a really good thing to do is, for any chunk or block of code like this, is to declare all of your variables together at the top, because as the program's going through, you've got to declare them before you can use them anyway. But if you declare them right before you use them every time, sometimes that makes a little bit of sense. But if you do that, then you'll find yourself reusing something. Where did I declare that? And then you're going through a hunt and seek for where did I declare that. So it's a good practice here to go ahead and have a section for any little block of code such as this, where you declare your variables. Alright, this is how easy it is. Remember, a variable has a type, so it's a type of variable, and then you give it a name, or technically called an identifier, and it has a value. We won't look at giving our variables values until the next section, but there's nothing to it. So to just declare a variable, we're reserving that space. You need to say what type it is. Now, we've used this in the past. We're going to get into numeric types and stuff later in this topic, and then the character type, but that is for an integer type, just so you know. But we'll get into that in more detail later in the topic. So you need the type, then you need a name. I'm just going to give it my int. Alright, and then you follow it with a semicolon. So if you remember from previous videos, C++ statements end in a semicolon. See where they're popping up everywhere when I highlight that? So don't forget the semicolon. It's a very common mistake, especially for newer programmers, but truth be told, occasionally I'll leave one out. Anyway, so that's all it is to it. You've just declared that. So what have you done? Let's take a quick look at the graphic from the previous video. What you have done is you've got your type and the name or identifier, and so you've said, alright, I want to reserve memory that's let me go ahead and full screen this here real quick. I want to reserve a chunk of memory that's the size of an int, the int type, and I want the data to be formatted as an int. Furthermore, I'm going to refer to that chunk of memory by the name, which I gave it the myInt name. So that's what that simple little statement does. I told you in the last video it's going to be really easy, and sure enough, That's all it is to it. So your program has now said, all right, I'm going to request this memory and it's going to be formatted that way and it's going to be called my int. That is all there is to it. Now, just for demonstration purposes, I'm going to type something. Don't worry about the syntax. I'll just tell you what it's going to do. What it's going to do is it's going to give the memory address my int of my int. It's going to output it to the screen. Okay, that's what it's going to do. All right, and you'll see. Let's see, we need to rebuild and everything. Hopefully, we don't have any syntax. There we go. All right, that is it. I'm going to click a couple of times so you can see where my mouse is. That is it. That is actually the memory address where that variable is located on this machine right now. This is more or less a binary number. It's hexadecimal. It's just a shorthand for binary. When I say shorthand, you don't lose any information. Essentially what it is each one of these digits represents one of 16 possibilities, and those 16 possibilities are equivalent to 4 bits. So each one of these digits is equivalent to one of combination of 4 bits, represents 4 bits, each one of these digits. But anyway, so look at this. All right, we'll just look at these last 4. F890. Now, our program's going to terminate. Let's run it again. Uh-oh, that's FDB4. All right, so that is to demonstrate that every time you run your program for any given variable, it's going to be in a different location in memory. So what happens is when the program runs, it requests a chunk of memory from the operating system, and then it takes whatever it can get. Okay, it just, all right, whatever the operating system gives the program, that's it. But it doesn't just give it the memory, it gives it the memory address. And so this little bit I've said output what the memory address is for this variable, and as you just saw, it changes every time you run the program. But you don't have to worry about that. All you have to worry about here is the name, the identifier for your variable, and you can use that, and it'll compile it, and then whenever it runs, the program's going to keep track of what that actual memory address is. Okay, it's going to know. Okay, it works with the operating system to do all that. It doesn't do it all by itself, but it's that's how that works, and that is why we use things like identifiers. All right. All right. Excellent. Now, we did spend quite a bit of time talking about names in this section, so I'm going to take a quick little look at some of that. Now, we did mention that there is a way to declare. Let's say you want to declare a whole bunch of ints. And we're going to show you that just so if you see it somewhere else, you know what's going on. All right. But we don't find this to be, the best practice, because it's a whole lot easier if each one is on a separate line. However, you may see this. What this is going to do is create 2 different ints, completely separate ints. This is the type. So it's going to create 2 of them. One is going to be called this and have its own, is going to be associated with its own chunk of memory, and this one's going to have its own chunk of memory, and that's how they're referred to. Pretty simple, but if you were looking at some code somewhere and you came across something like this, you might be like, what in the world's going on? It's like, well, it's there. like that. That was just a, you can't see that. That's a semicolon so that we can go around. We think, though, that it's much better to put each one on a separate line. Yeah, that can get long, and some people will disagree with that. They're like, oh, that's just a waste of space. We don't think so. So that's there. One other thing that was not mentioned directly in the course, it might seem somewhat like obvious, but it may not. So let's go ahead and take a quick look at what happens if you're going along and you name a variable, then you name another one the same way. Okay. Let's see what happens. It's not going to compile, I can go ahead and tell you. No, we don't want to run the last one. Alright, int my int redefinition. Okay, so you can't have two different variables like this, particularly, well, yeah, you can't with the same name, because it, once you get down here, you know, this says the memory address. Okay, well, for which one of these? You can't, and it won't let you. It won't let you have that, and you'll find it, and you might come across that error if you forget, oh yeah, I've already named something that. So yeah, you don't want to do that. Let's change this back to name int. Alright, there is just for being thorough, you can end up with a lot of different variables with the same name if they're in a if they're not in the same scope. In other words, so they don't overlap. But we haven't gotten to scope yet. Don't worry about that. Just, you know, you can't have two variables with the same name, because then it wouldn't know which memory address to that you want. Okay, so that's that. Now we talked about there's 4 little things on the checklist. One is, remember, we'll review very quickly, you can't have spaces in your name or in your identifier name. So if this is here, alright, I say do this, and we try to do that. Would you like to build it? Yes. See, you already got a squiggly here. No. Alright, expected semicolon, missing before identifier. See, so undeclared, if you start saying things about identifiers, see, what it's thinking is, okay, this is some other something. Anyway, it does not like it. So you don't want to do that. There you go. Alright, so you can't have spaces. As a matter of fact, you can only have 3 different types of characters. You can only have underscores and letters and numbers. Alright, this will actually compile just fine. So you can't have, like, you know, stars or anything else in it and all like that. Alright, but essentially, alright, you're limited to those. You can name it pretty much whatever you want as long as it's not some type of keyword. And if it is a keyword, it shows, you know, it'll glow blue when you're typing, so you'll know if you accidentally type a keyword. There's one other little limitation. Let's try putting that, well, I was going to put a 9 in here. Let's say 9. It doesn't matter, whatever number. See, you're already getting a squiggle, and it says expected an identifier again. So your little error message is about identifier. So you can't start with numbers. As you just saw before, you can start with underscores. All right, but you can't start with numbers. You can start with underscores or letters, but not numbers. But you can have numbers anywhere else in here. So this is definitely not good form, but it's the syntax is legal here. All right, so that will compile. All right, see, it compiles. So by syntax, that's legal. Now, since we can't have spaces, we talked about here in this section, Camel Case, and you can see how that's done. Okay. So what you do is, let's say I wanted it to be called name int, like this. So instead, since we can't have spaces, what you do is you just drop the space and capitalize the I. And this, believe it or not, this is going to be very easy to read once you get used to it. You won't miss the spaces at all. I mean, you'll just see it and know. Anytime you see Camel Case, you'll just be like, oh, that's an identifier. You know, it's a name of something. So pretty easy, and that's what we use in this course. Some folks like this, and that's more of a convention. It's a convention that's used more often to delineate between different things in some languages like C#. Okay, and that's called Pascal Case. And the only difference is you've got that there. The first one is capitalized. Now, if you want, so that's your Camel Case. If you wanted a longer something, you say that I want to use. Okay, there you go. So you can see this Camel Case. But even still, if your name gets too long, I mean, who wants a name like that? Now I used a whole bunch of really short little things here. That's not quite so easy to read, especially with that I there. But that's something else here on the checklist. You want it to be you want it to be short but descriptive. Now, we're not really doing anything in this program, so it's kind of hard to say, describe what. You could say something else like number, I'm trying to think of something with 2 letters, number of oranges. Okay, you could potentially shorten this. The idea is you want to keep it short, but you want to be able to see, oh, okay, this is what that variable represents. Now, the last thing on our checklist was that these should be nouns. Okay, and why is that? This represents some type of value. Like, this is the number of oranges. So we're talking about oranges here. So and here we're talking about an integer or something. We're talking about a thing. So the last thing on the checklist when you're creating names for variables, now this is for variables. In part 2, when we get to functions, functions actually do things. So when you name those, you should give them verbs. And that just helps make everything much more clear. All right, there you go. See, I told you it was going to be easy. There is nothing to it, but you've seen exactly how this works, and how it relates to our diagram from before. And in the next, let's see, we'll go ahead and make sure that is saved. In the next section, you'll learn how to give those variables a value. Okay, and you'll also learn how you can change that value. So we'll see you then, and in the video in that section. This concludes another video for Introduction to Programming with C++, brought to you by LogiKomp. You can access the full course by going to the course homepage at logikomp.com/introcpp. While we are proud to offer this course free of cost to individuals, we do ask that if you continue to use the course, that you support its production and maintenance by making at least a small purchase from LogiKomp Domains and Hosting. You can pick up a custom domain, renewable annually, for around $10 at logikomp.com/hosting. Thank you.